Welcome students. We are back with another lesson. In this lesson, we'll discuss mirror formula. So in this topic, we will state the mirror formula and we will verify whether the mirror formula is applicable for both concave and convex mirror. Now, this is your mirror formula. 1 by u plus 1 by v equals to 1 by f. Now, according to this formula, 1 by u, where u is your object distance. That means, let us consider your concave mirror. For the concave mirror, let us suppose this is my object, AB. Fine. Now, the distance of the object from the pole. And how much is this distance? PB. This distance is P to V. This is your object distance by small u. Fine, as you can see, this is denoted by small u. Similarly, for your convex mirror, if this is your convex mirror, let us consider you have an object. This is your object AB. Now again, your object is placed at what distance? It is placed at a distance of PB from the pole of the mirror. So again, this distance will be denoted with small u. So what is your object distance? It is the distance between the object and the pole, which is denoted by small u. Fine. Similarly, let us consider if this is your object. If this, let us consider your concave mirror. Now in this concave mirror, if this is your object, AB is your object. Now this object AB forms the image A dash B dash. This is the image A dash B dash. Now at what distance the image is formed from the pole? The image is formed at a distance P to B dash. Clear? P to B dash, and it is denoted by small v. So small v is your image distance. So your image can be written as P to B dash. Fine. And it is denoted by small v. Let us consider your convex mirror. If this is your convex mirror, fine. This is your object AB. This object AB forms the image A dash B dash. Can you see? This is the image. Now at what distance is this image from the pole? It is at a distance PB dash. Fine. And this is denoted by small v. Fine. So V is the image distance PB dash for both concave as well as convex mirror. And finally F. So what is F? F is the distance. Can you see this point? This point. For a concave mirror, this point represents the principal focus. Fine. So F is the distance between the principal focus and the pole, which is denoted as PF and can be written as small f. Fine. So how much is your focal length? Can you see this distance? This distance represents your by small f. Fine. So PF is your focal length denoted by small f. P to F. Fine. And it is denoted with small f. The same can be used for your convex mirror. This is your convex mirror. This is your principal focus, this point. Fine. So the distance between the pole and the principal focus, this distance is your focal length and it is denoted by smaller. Fine. So this is your mirror formula. So what does the mirror formula states? 1 by object distance plus 1 by image distance equals to 1 by focal length. Fine. And this mirror formula is applicable for both your concave mirror as well as your convex mirror. Fine. Next, we will derive the mirror formula. So derive, next topic we'll discuss derivation of mirror formula for your concave mirror. So we will discuss the derivation for concave mirror. The same can be applicable for your convex mirror. Fine. Okay. Before we derive the mirror formula, let us revise the concept of the similar triangles. Okay, this similar triangles is not in your syllabus of physics. Okay, this is a concept, or this topic has already been done in your class 9 and your class 10. Okay, but for our derivation we will require this, the concept of the similar triangles. Okay, so so let us revise what are similar triangles. Okay, so similar triangles have the same shape. Okay, if two triangles, can you see in this figure, if they are of the same shape, they represent the same type of triangles, then they will be similar triangles, but not necessary that they have to be of the equal size. Okay, but not necessarily they should be of the same size. Fine. The next is your, the next point is the second point. It is an important point. The corresponding angles are equal. Fine. If you show that two triangles are similar, if these two triangles are similar, then the corresponding angles will be equal. So this angle, let us suppose this angle is equal to this angle, x equals to x, x equals to x, and your angle y equals to y, and angle z equals to z. Fine. Similar, then their corresponding angles should also be equal, as you can see in this figure. Fine. Now the third point, which is a very important point, if the triangles are similar, then the corresponding angles are equal. If the corresponding angles are equal, then the corresponding sides are in the same ratio. Fine. The sides should be in the same ratio. So what does this mean? Now look at this angle, angle x. Now which is the side opposite to your angle x? The side A. Fine. Now similarly on this side, opposite to this angle x, what is the side? P. So the ratio of A by P should be equal to, now consider the another corresponding equal angle, consider this angle y. In this triangle, the side opposite to angle y is B. Fine. So I'll write B. B by, what is the side opposite to this angle, the corresponding equal angle on the other triangle? It is Q. So the ratio A by P should be equal to B by Q. Similarly, what is the side opposite to this angle, angle Z? Which is the side opposite to this angle? It is R. Fine. Similarly, which is the side opposite to this angle Z? It is C. Two triangles are similar, the corresponding angles are equal, then the corresponding side ratio should also be equal. That means A by P should be equals to B by Q, which in turn equals to C by R. Fine. Now there are these three properties to test whether the two triangles are similar or not. Fine. So the first property is AA. Fine. So according to this property, AA stands for angle. If two angles are equal, suppose angle X and angle X, they are equal, angle Y and angle Y are equal, then automatically the third angle, can you see this third angle Z and this Z, both of them will be equal to the sum of triangle of properties. Fine. Let us consider, take for example, this is 60°, this one is also 60°. Okay, consider this angle is 60°, angle X is also 60°. Now you know from the sum of triangle of properties, by using the sum of triangle of properties, that means the sum of all these three sides, the sum of all these three angles should be how much? 180. If it is 180, then how much will be this third angle? Similarly, in this case, what will be the third angle? Okay, do the calculation yourself and check. It will be 60°. Fine. This one will also be 60°. If the two angles X and X are equal, Y and Y are equal, then automatically the third angle of the triangle Z and Z will be equal. This is your AA property. Okay, so according to this property, if you can show any two angles of the two triangles similar, then the corresponding two triangles will be equal. Fine. Okay, the other property is triple S. That means if the side and side, the corresponding sides are equal, then also I can show that the two triangles are similar. The other property is SAS. That means if this side and this side are equal and the angle between the two equal sides are equal to the second triangle, then in that case also I can show that the two triangles are similar. Fine. Okay, I will use only this property AA. Fine. So I have explained you AA in detail. Fine. No need for this SAS and SS. Fine. So you remember this one. If two triangles are similar, the corresponding angles are equal, the ratio of the corresponding sides should be equal. This is very important. Okay, I will use thoroughly. And next is that if the two triangles will be similar, I can use this property to show them that they are similar. Okay, now while deriving, I won't explain, I won't go into detail every time showing why they are equal. Okay, whenever I say the two triangles are similar, you can simply use this concept, the concept of AA. Fine. So let's move to the derivation part. Now consider you have a concave mirror. This is your concave mirror. Fine. Now consider a object. This is your object AB. Fine. This is your object AB. Now let us consider the first ray which moves from the point A. It goes from left to right direction. It strikes the mirror, and after reflection it will pass through the principal focus capital F, and it will move in this direction. Fine. So this is your first ray. Now let us consider the another ray from your object AB. So this is your second ray. It goes and it strikes the mirror at the point P. Now when it strikes the mirror at the point P, it undergoes reflection. In that case, what happens? In that case, the angle of incidence made by the incident ray will be equal to the angle of reflection made by your reflected ray. Fine. So from this principle, the reflected ray will follows the law of reflection and will move in this direction. Fine. Now let us consider your third ray. The third ray passes through your center of curvature. Fine. This ray will pass through the center of curvature. It will strike the mirror and then it will move back along the same path. Fine. So these are your three rays. Now consider the point where the three rays are intersecting. Fine. This is the point where the three rays are intersecting. So at this point, the mirror will form a real image, and this real image is A dash B dash. Clear? This is your real image A dash B dash. Fine. Now if AB is your object, AB is your object, then this distance P to B is your object distance. Fine, this is your object distance. And how we denote object distance? We denote object distance with small u. Fine. So your object distance P to B. This is your object distance. But note, this is the direction of the incident light from left to right. Fine. And we are measuring the object in the opposite direction. Can you see? We are measuring from point P to point B. In that case, according to the sign convention, whether it will be positive or negative, negative. So your object distance PB equals to minus U. Fine. So if you have any confusion with the sign convention, I'll suggest you to go back to my previous video and first go through the sign conventions before you move to this lesson. Fine. So in our case, the object distance P to B will be minus U. Fine. Now let us consider your image. This is your image A dash B dash. This image is formed at what distance? This image is formed at a distance PB dash. Fine. The image distance is PB dash. Now again, look here very carefully. We denote our image distance as small b. Fine. Now this direction, in which direction we are measuring our image distance? We are measuring from right to left, from point P to B dash, which is opposite to the direction of the incident light. So therefore it will be negative. So image distance PB dash equals to minus V from the sign convention. Fine. Finally, your focal point, the distance between the point P and your F. Okay. So instead of PF for our understanding, fine. Write this one as PF instead of writing FP. Okay. See, while noting down this points, okay, this one doesn't matter. Okay, which one comes first, whether you write P first or F first doesn't matter. But what matters is that according to the sign convention, the distance should always be measured from the pole. The distance should always be measured from the pole. So to avoid any further mistakes, what we will do is we will generally write the pole first, then the corresponding point later. So if you write FP or PF, they denote the same distance. But what we have to remember, we have to always be measured from the pole first. Fine. So let us come to this focal point. This F is your principal focus. This is your pole. So what is your focal length? The distance between the pole and your focus, capital F, which is denoted with small f. Fine. So PF is your focal length, and again it is measured in the direction of the incident light or opposite to incident light? Opposite to incident light. Therefore, this will be in the negative direction. Fine. So the focal length PF equals to minus F. Similarly, the final one, the distance between the pole and the center of curvature C. This distance. Fine. This distance. Fine. This distance denotes your radius of curvature. Again, your radius of curvature will be positive or negative because it is measured in the direction of the opposite to incident light. Fine. Now, one more point. Okay, we have already discussed that your radius of curvature equals to twice of f. Fine. The radius of curvature is twice of the focal length. That means this, the distance shown by this red line. Can you see this red line? The distance shown by this red line is twice the distance of this blue line. Can you see this blue line? Fine. Radius of curvature is twice the distance of the focal length, which is equals to 2f. Negative. So your focal 2f will also be a negative quantity. Fine. So after defining your object distance, your image distance and your focal length, okay, now we will try to derive a relation between these three physical quantities, your object distance, your image distance and your focal length. First, consider two triangles, your triangle ABC, this triangle, and consider triangle A dash B dash C. Okay, fine, this triangle. Now both they are similar to each other, isn't it? If they are similar to each other, by the property of similarity, I can write A dash B dash by AB. This side, A dash B dash by AB equals to CB dash, this side, CB dash by BC, this side, CB dash by BC. Fine. Now look here very carefully. Consider this distance. How much is this distance? This is PC or your CP. This distance is CP. Now from this distance, if I remove this much distance, if I remove PB B dash P, fine. So what am I left with? I'll be left with this much length, which is B dash C, isn't it? Your CB dash can be written as CP minus B dash P. Fine. Similarly, this side BC, this side BC can be written as, consider this distance BP. Consider this distance BP. Fine. Now from this distance, if I remove this much distance, fine. If I eliminate CP from here, so I'll be left with BC, this blue line. Fine. So CB dash can be written as CP minus B dash P and BC can be written as BP minus CP. Fine. Now, as we have already defined this distance CP. What is this distance? Radius of curvature. Fine. And it is measured in the opposite direction. So according to sign convention, CP is minus R. Similarly, what is B? Image distance V. Fine. This is your image distance V. According to sign convention is negative. Fine. So this negative and this negative, what it will become? It will become positive. So I'll write simply plus V here. Fine. Similarly, BP. What is BP? BP, this distance is your object distance, small u. Fine. So BP is your object distance, small u. And what is CP? What is this distance? CP. This distance represents your radius of curvature. Fine. And again, this is how much? This is minus of R. Fine. Now this minus, and this minus gets cancelled. So I'll have plus R. Fine. So A dash B dash by AB can be written as minus R plus V divided by minus U plus R. Fine. Now, as your angle A dash PB dash equals to angle APB, your angle, this angle A dash PB dash, this angle, fine. This angle equals to APB, this angle. This angle equals to this angle. Okay, why they are equal? Because this is your angle of incidence, this is your angle of reflection. Fine. According to the laws of reflection, the angle of incidence should be equal to your angle of reflection. Fine. So these two angles are equal. If these two angles are equal, therefore I can also show that this triangle ABP and your triangle A dash P B dash. Fine. Triangle A dash P B dash, this triangle is similar to your triangle APB. Fine, this triangle. Okay, this yellow and the blue triangle are similar. Principle of similar triangles, I can write the ratio of the corresponding sides. A dash B dash divided by AB. A dash B dash by AB equals to B dash P divided by BP. B dash P divided by BP. Fine. Now B dash P, this distance, B dash P, what does it denotes? It denotes your image distance V, and it is in the opposite direction, so I'll write down minus V. Similarly, this distance BP, fine, this is your image distance BP. Sorry, this is your object distance BP, and how we denote object distance? Small u. So we can write minus u, fine, according to the sign convention. Now look, this minus and this minus gets cancelled. So A dash V by U. Right. So this is my equation 2 and this is my equation 1. Now since my equation, both of them are equal to A dash B dash by AB, A dash B dash by AB. Therefore, from equation 1 and equation 2, I can write minus R plus V minus U plus R, minus R plus V minus U plus R equals to B by U, from equation 2 equals to V by U. Fine. Now I can take this U and I can multiply on the numerator. So U times R is minus UR, U times V is plus UV. Similarly, I can take this one to the numerator and I can multiply with v. Fine. So if I multiply this one in the numerator, what is it? It is u plus. So v times minus u will be minus uv, and v times plus r will be vr. Fine. Now look here, this is minus uv, this is plus uv. So I can send this uv, I can send this minus uv to the other side. If it goes to the other side, it will become plus. So uv plus uv will be twice of uv. Fine. And now this distance minus ur, I can send it to the other side. So if I send it to the other side, what will happen to this negative sign? This negative sign will become plus. So it will be ur. Fine. I've written Vr plus Ur. On the right hand side, I've written twice of UV. Now, if I divide this whole equation by, let us divide this one by U, V, R. Similarly, divide this equation by U, V, R. Similarly, divide this equation by U, V, R. Now look here. First term, this v and this v gets cancelled, this r and this r left with only u term. Therefore I can write 1 by u. Similarly, this u and this u gets cancelled, this r gets cancelled with v. So I can write 1 by v. Fine. On the right, this u and this u gets cancelled, this v and this v gets cancelled. So what I'm left, 2 by r. So I can write 2 by r. Fine. But we know the radius of curvature is twice of f. So instead of twice of f instead of r. Now if I write twice of f, what will happen? This 2 and this 2 gets cancelled. So 1 by u plus 1 by v, 1 by v equals to 2 gets cancelled. I have 1 by f equals to 1 by f. Thus we have proved our mirror formula for the concave mirror, where it forms a real image. Fine. So the similar thing can be derived for your convex mirror. Fine. Fine. Moving to our next topic, linear magnification. In this topic, we'll define magnification, and then we will write the expression for the magnification for concave mirror as well as your convex mirror. Fine. So linear magnification. What is linear magnification? The linear magnification is the ratio of the height of the image to the height of the object. Fine. Now suppose this is your concave mirror. Okay, this is your concave mirror. Fine. This concave mirror has an object AB. This is your object AB. This object AB forms a image A dash B dash. Fine, this forms an image. Now let us consider the height of the object. The height of the object, let us denote it as h1. Now consider the height of the image or the size of the image. It is denoted by h2. Fine. So according to your linear magnification, which can be written as small m. Fine. According to the linear magnification small m, this small m equals to the ratio of the height of the image, the height of this image, which is h2. Fine. h2 divided by your height of the object. This is the height of the object, which is h1. Fine. So your magnification m equals to h2 upon h1. Fine. Okay. Now let us consider a concave mirror. This concave mirror has an object AB which is of the height h1, right? And this object AB forms the image A dash B dash which is of the height h2, fine. Now in this figure, okay, consider APB, fine. Consider this triangle APB and your okay, consider this two and your triangle A dash B B dash, fine. Similar. Now if these two triangles are similar, then I can write the ratio of the corresponding sides as equals. So A dash B dash, this side A dash B dash divided by AB divided by AB equals to this side B dash P upon BP, fine. B dash P upon BP. Yeah. Now let us apply the sign convention. Now in this case, your object, okay, this is measured in which direction? From B to A. It is in the upward direction, so it will be positive, fine. So your object distance AB will be plus h1, fine. Whereas your image height, consider this distance A dash B dash, fine. This is measured in the downward direction from B dash to A dash. So this will be positive or negative? It will be negative, fine. So the height of the image is minus h2. Now this is your image A dash B dash. It is at what distance from the pole? It is at a distance V, small v. And again, it is measured in the direction of the incident light or opposite to incident light, opposite to incident light. So therefore, it will be negative, fine. So the image distance will be negative. So as your object distance, what is your object distance? This is your object distance PB, and it is measured in the opposite direction to the incident light. Therefore, my object distance will be minus of u. Fine. Now let us substitute this values here. A dash B dash is minus h2. So instead of A dash B dash, I'll write down minus h2. What is AB? AB is your plus h1. So instead of AB, I will write plus h1. Next, your B dash P. Your B dash P is your image distance minus V. So instead of B dash P, I'll write down minus V. Fine. Now, the next one, BP. Your BP represents your object distance, which is how much? Minus U. So instead of this one, I can write minus U. Fine. This minus and this minus gets cancelled. Fine. But I can send this negative sign here. So instead of this, I can write h2 by h1. If I send the negative sign to the other side, what will happen? It will be minus v upon u. Fine. So now what is h2 by h1? h2, the height of the image by height of the object. It is known as your magnification, linear magnification m. Fine. So this is your linear magnification h2 by object distance and image distance. I can write b upon small e. Fine. So this magnification formula, okay, is concave mirror. Fine. If this is your object height h1, this concave mirror forms an image, let us say at this point. Okay, this will be In this case, what kind of image will your convex mirror form? The convex mirror will make a virtual image. Okay, this is your virtual image. In that case also I can write the magnification formula as m equals to h2 by h1. Fine. Which can also be written in terms of object distance. Okay, this distance represents your v. Fine. And this distance represents your u, and add a negative sign. Fine. So this mirror formula is also applicable for your convex mirror. Fine. Okay, now finally your m is your linear magnification, which the ratio of the height of the image to the height of the object. Height of the image is denoted by h2, height of the object is denoted by h1. Fine. If magnification, this mod, okay, this mod means we are considering only the numerical part. Okay, then only the number part. Suppose if I write -2 or if I write +2. Okay, it does not matter. If I put a mod sign, then I am considering only the magnitude of positive quantity or a negative quantity. So that only the numerical part. Fine. So if mod m is greater than 1, okay, if m is greater, it means h2 by h1 is greater than 1. If h2 by h1 is greater than 1, what does this means? h2 is greater than h1. Fine. If h2 is greater than h1, what does that mean? It means that the height of the image form, okay, the height of the image form, suppose this is your h2, this is the image formed by your object. Okay, so your object will be somewhere at this point. This is your h1. Fine. So in this, the height of the image is larger than the height of the object. In that case, what will happen? You obtain a bigger image. So I can say the image is magnified. Clear? If m is less than 1, what? h2 by h1 is less than 1. That means height of the image h2 is smaller than the height of the object h. Image will be small in, sorry, the image form will be small in size, or I can say the image is diminished. Fine. D I M I N. Fine. The image is diminished. Fine. Now finally, when your magnification equals to 1, that means h2 by h1 equals to 1, which in turn implies that h2 equals to h1. Fine. That means the height of the image is equal to the height of the object. The image is same size as object. Fine. The image form will be the same size as the object. So that's it for today's class. Thank you. And if you have any confusion or doubt at any point, so please don't hesitate to ask. I will re-explain it to you again. So thank you.